So in this video, we're just going to answer a couple of questions on some of the key definitions and features of network diagrams that we have covered in the previous couple of videos. So you can see on the right here, I have a network diagram, and we're just going to answer a couple of questions. So we're just going to kind of revise the main definitions and think about how we can answer these. Now, basically at this stage, it's really just counting. That's all we're really doing with our network diagrams. Now it's saying find the number of vertices. Now, if you remember our definitions, the vertices of this diagram are just the dots that we can see. So we see A, B, C, D, and E. So there are 5 vertices in this network diagram. In part B, it's saying the number of edges. So we are just counting the lines that connect the different vertices to one another. So if we count them, we have 1, 2, 3, 4, 5, 6, and 7. So we have 7 edges on this network diagram. Now for part C, it's asking us for the degree of vertex C. So if we just consider, if we just consider vertex C, that is this guy over here, we're trying to find the degree of this vertex. Now, thinking back, the degree means how many edges are connected to this particular vertex. So we can see that C is connected to D, that's the first, second to E, third to A, fourth to B. So the degree of vertex C is 4. And part D, it is asking us to find the number of vertices of odd degree. Now we can see that vertex C has an even degree, has a degree of 4. So we're just going to look at all of these different ones and see which ones have an odd degree. Now if we look at B here, it connects to 1 and 2. So that's not a vertex of odd degree. A, however, connects to 1, 2, 3. Okay, so that's our first vertex, which has an odd degree. You can see as well that vertex E has 1, 2, and 3 connections. So E has an odd degree and D has an even degree. It only has 1 and 2 connections. So the number of vertices of odd degree is just 2. So we're just kind of recapping the main definitions and applying them to some questions here. Now, if we go to example 2, similar kind of thing, but the question's a bit harder because it has a different feature here. Now, the main one that I'm talking about, the different feature, is this loop here. So we'll talk about that when it becomes relevant. But going into this one, we're once again just kind of counting. So part A, it's saying to find the number of vertices. So we have A, B, C, D. We have 4 vertices. Part B, number of edges. So we have, let's count them. 1, 2, 3, 4, 5, 6. Now remember, a loop only contributes 1 edge. It has a degree of 2, but we only think of a loop as 1 edge. That's what makes it a little bit tricky to deal with. But the number of edges here is 7. Part C, it's asking us for, if we just rub this all out, part C is asking for the degree of vertex B. So we want to see how many different edges are connected to B. What is the degree of it? So we can see it's connected to 1, 2, 3, 4. There's 1 edge on this loop, but remember it contributes a degree of 2 to the vertex, to the degree. So it has 4 connections here, but the loop counts for 2. So it has a degree of 6 altogether. I hope that makes sense. That's a tricky part about loops. They only contribute 1 to the number of edges, but they contribute 2 to the degree of a vertex. Now part D, it's saying the degree of vertex D. We can see it's only connected to A here and B. So it has a degree of 2. Now part E is asking us for the number of vertices of odd degree. So let's just look at those. Now we can see that it's a couple of these B and D have an even degree. We've counted that before. So we're just going to look at the other ones. Now C has 1, 2, 3 edges that it's connected to. So that's a vertex with odd degree. And A has 1, 2, 3 other vertices that it's connected to. So A and C have an odd degree. So the number of vertices with an odd degree is 2. And B and D, we already said, had an even degree. So there's only 2 vertices with an even degree. So we're just getting used to navigating these network diagrams, identifying what a vertex is, what vertices are, identifying number of edges, and then finding the degree of all of our vertices. That brings us to the end of this video. Thank you so much for watching, and I'll see you next time.